Hey guys, just want to encourage you to really take hold of your own learning and own your own learning. I'm putting all this stuff out here. There's things I want you to do, things that I think will be helpful. But in the end, I really just want you to learn the mathematics so that you can be successful. So there are things that I put in the videos that I feel like are important for you to think about. And I would be a little hesitant if you would told me you just were skipping all the videos and going straight to the assignments. But do what's working for you. For example, this activity, I'm just going to go through class activity 9.0. I would encourage you to pause this right now and go through the activity yourself. See how you do, see what questions you have. At the end of the day, if you've got the activity, you can kind of flip through the video and see if you got the same answers I got, or if there's any questions you have, you can watch that part of the video. That's completely fine. So with that said, I'd encourage you to pause the video. I am going to go through it all step by step, but this is a video I would definitely encourage you to skip parts if you're able to. So go ahead and pause it and then start back up when you're ready. All right. Let's take a look. It says number 1, to make concrete, you need 3 times as much sand as cement. When Aaron was asked to do this, here's what he wrote. S equals sand, C equals cement. Hopefully you're seeing an issue with his labeling, his defining of variables. Instead of saying S equals sand, it would be more helpful if he would put some sort of label or measurement on there. So actually when they make mortar for laying bricks, they actually use shovelfuls. So you could put in S as the number of shovelfuls of sand and C is the number of shovelfuls of cement. Sometimes it's more exact, but that's really what's used there. I'm going to use pounds. You could probably use gallons or something else here. So S equals the number of pounds of sand. C equals the number of pounds of cement. And it says you need 3 times as much sand as cement. Now, a couple ways to do this. It mentions a strip diagram in a future videos. Next week we'll take a look at strip diagrams a little closer. But strip diagrams are just a way of visually representing sand and concrete. So if this is sand, then we want to draw how big concrete would be. We need 3 times as much sand as cement. So which one is more, sand or cement? Hopefully you're seeing we need cement to be smaller. So here would be just a strip diagram. It would show that concrete, each of these rectangles is the same, so sand is 3 times more than the cement. All right, now let's look at Aaron's equation. He says 3 times the pounds of sand equal the pounds of cement. Well, we could see if we took 3 of these, 1, 2, can't even draw it, 3 of those, well, that's clearly not equal to the cement. And so we can see this is backwards. We need to do 3 times the pounds of cement equals the pounds of sand. All right, again, pause it if you need to. But question 2, a company prints t-shirts with original designs. To create a design, the company charges $75. Each t-shirt costs $12. So how many t-shirts is it cost for one design? So 20 t-shirts, that's going to be 20 times $12 for each, plus the $75 setup fee. Then we have 25 t-shirts times 12 plus 75, and so on. 35 times 12 plus 75. And you can probably guess where this is headed. Define, and this time it's asking 2 variables. So what are my 2 variables? Well, we'll let T equal the number of t-shirts and C equal the cost. Maybe I should put total cost in there. My equation then is the cost equals t times 12 plus 75, or more standard notation would be to put the coefficient in front of the variable. Here we have another problem working with t-shirts and shipping. Company sells mail order t-shirts. They charge $11 for each t-shirt and $8 for shipping, no matter how they were ordered. We see the two different work that students do. Do you remember what this kind of work is called compared to this? Hopefully you're remembering additive reasoning versus multiplicative reasoning. Okay? And we've talked about this already. Which was more useful? I would say the multiplicative, because it sets it up for variable expression. We can see the t-shirts that vary here. Otherwise, everything else remains the same. So, similarly, we could set this up. Let t equal the number of t-shirts. And let c equal the total cost. This time c equals 11t plus the $8 shipping. All right, another t-shirt problem. Now they have 500 t-shirts in stock. Starting tomorrow, they expect to sell 15 every day. Eventually, you're going to start to get comfortable and be like, oh, okay, well, I'm looking for how many days have passed. So I'm going to let d equal number of days passed. And let t equal number of t-shirts remaining. And so you can set up t equals, they started with 500, and I'm going to subtract 15 every day. So if you want to test it out, you could just say, okay, what about when d equals 1? So on 1, then my t-shirts, I should have 500 minus 15, 485 left. Plug this in, does it work out? And you'll see it does. If you can't jump straight to here, my advice is to think about this and think about it multiplicatively if you can. 500 minus 2 times 15. 500 minus 3 times 15. No, erasing too much. And then you can see that eventually we can replace it, and that just becomes 15d. All right. So, class activity 9.0, here it is. Got this picture, this page, and this page.